Well, I suppose I should say good morning, but I'm from the East Coast, and so my body's craving lunch at the moment, so good morning doesn't seem kind of appropriate. But I'm talking about architecture, and this is kind of an odd thing, because the reason I'm up here talking is because the organizers said, we'd like you to talk about software architecture in 10 minutes. Okay. But architect has always been an slightly awkward thing for me. I don't really like the term software architecture because it summons up these images of some senior person in an organization who is setting rules and standards for how software should be written, but hasn't actually written any software for maybe 10 or 20 years. And these architects, Joel Spolsky used the term architecture astronauts, often cause a lot of problems for software projects. And so the whole term architect and architecture has that kind of nasty taste to it. And this is particularly something that we need to change as an industry because the way we write code is important. When we have that opening little thing at the beginning of a show, you see little bits of software code put in there. And that's because the open source community has always believed code is important. That if you're going to be a technical person, you have to be someone who's familiar and comfortable with the act of programming. And of course, there has been for quite a while, in architecture particularly, this notion that architecture is kind of beyond programming. And if you're an architect, you shouldn't be programming anymore. And that's something that I've always felt is very wrong. But that then only raises the question, well, what really is architecture? What does even the word mean in a software context? Because, of course, we're borrowing the term from buildings and construction, where it actually means something completely different. And I won't go into all of that. If you want to come up with some kind of official definition of what architecture should be, this is probably the closest you might get. IEEE software standard. And that kind of definition has been around for a while. But when I think of what architecture ought to mean and does mean, I actually think of a reaction to a statement like that that was made by this guy. I don't know how many of you recognize him. This is Ralph Johnson, probably best known as one of the authors of the Design Patterns, the Gang of Four book. He's also, and work by people like him has been a major trigger for my career in the sense that it was his students that originally formalized the notion of refactoring, that actually wrote the very first refactoring tools. So I've nicked a lot of stuff from Ralph and his folks over the time. And he sent an email once that was a reaction to that definition of architecture. And I liked it so much that I ended up stealing it completely. And this column on architecture that I wrote over 10 years ago for IEEE software basically takes the entire email and pads it out a bit to be the column. And you can find it if you want to hunt around for it. And he basically took this definition and said, the problem with this definition is that it relies on this notion of somehow what are the highest level, most critical, important components. A lot of the earlier versions of this talked about the highest level concerns in something. And he said, well, what does that mean? How do you select which components? What relationships are important? There's obviously a gazillion components and relationships in a product. What matters to make some of them architectural and some of them not? And in his view, he said that, well, what really matters here is that if you go to a reasonably healthy software project and you talk to the expert developers on that project, the people who are most capable, who are most familiar with a code base, they will have some common understanding of how the thing works. And it's that common understanding that is effectively the architecture. And this is important because it is also brings out the fact that architecture is very much a social thing. It is that fuzzy embedded understanding that really matters. And yeah, there may be diagrams here and there might be documents here and there may have architecture written on them, but they're just a representation, and usually an imperfect representation of that shared understanding. And what you're trying to do with a software project, particularly as software projects grow, is you want to make sure you have a good shared understanding between the people who are leading the project. That's really what matters. But that definition, although it's very common, there's another one that's also quite important, which you also see, which is saying that architecture should be the decisions you need to make early on. And Ralph also was able to poke a hole in that one. He said, well, really, it's what you wish you could get right early on. Because the point is, the decisions you might need to make early, you don't have the information. You only learn about what the software product should be structured like as you're building it. And what it really boils down to is you're concerned about the decisions that are hard to change. And that is actually a quite useful way of thinking about architecture. What is hard to change? And it does lead to some different thoughts than what are the main components and how do they fit together. Because programming language, the choice of programming language, is a decision that's hard to change. But it isn't usually considered what are the top-level components. So having kind of taken these two routes, he then continues by saying, well, really we've got two things here, shared understanding and hard to change, but they actually boil down to really what, in his view, and I'm echoing it because it's in my view too, is the definition of architecture. And I hear the laughter, right, because that sounds like an almost silly statement, the important stuff, right, whatever that happens to be. But actually, I think it's a very profound statement. It says that if you're trying to think about your software system and what its architecture is, the first thing you have to do is you have to figure out, well, what is important? What do we, as the technical leadership of a project, consider to be the most important things in there? Or even on a solo project, what is the key things about this system? What is the most important thing in the code base that I have to keep at the top of my head when I'm working on it? That decision about what is important is really the key thing that goes on. And that is really the thing that trumps everything else. So that, if people ask me what my definition of architecture it is, I follow Ralph in this and I say it's the important stuff. So that talks about what architecture is. The next thing I want to look at is another question, which is, well, why should we care about software architecture? Why is it as important as, to have me come along and do a 10-minute talk about it? And really, the thing that triggers that is something like this that you hear from time to time. So how many people have heard something like this on a software project that they've been working on? You've heard this kind of line, we need to sort of, don't worry so much about modularity and these design ideas. We've got to crank out features. And the reaction of a lot of people to this is they get frustrated and they try to argue in terms of, well, we've got to do a decent job as software professionals. We've got to stand up to our professional standards. It's almost like taking a moral response to this and saying, well, software architecture is important for moral reasons. We need to do a good job. We need to be craftsmen. Unfortunately, my view is that if you take that line, you've lost. As soon as you start pacing that argument, you lose. Because what you're doing is you're making a battle between craftsmanship and economics. And economics always wins. And if you want to say, well, why is architecture important? You have to instead cast it in economic terms. The problem with this argument up here, is it's got a notion of what is quality based on an idea that quality is something I can trade off for cost. We do this all the time when we buy things. When we buy cars, when we buy clothes, we do this trade-off on quality and cost. But quality in software means a whole bunch of different things. And the point is that some of these things, an external person, a user, a manager, a customer, they can see them, but some of them they can't. So whether your software has a good architecture, or a good modular design or whatever, that's not something that's visible. And so I think of it as saying, well, we've got two forms of quality here. that that's external and what's internal. And architecture is about internal quality. And the thing about internal quality is it is not directly visible. If somebody offers me a software product with great quality that costs $100 more than software that does exactly the same thing but has poor internal quality, what's my motivation to pick the great quality one? I'm going to pay $100 more for something that does the same thing. I'm going to go for the poor internal quality, surely. But what matters in terms of internal quality is more the long-term picture. And I have this rather convoluted statement that tries to sum this up. I call it the design stamina hypothesis. Horrible long-term, I know. But it tries to capture this. And I do it by plotting this pseudograph of the functionality of the software over time as it grows. And if you don't pay attention to design and architecture during the project, you get a curve that looks something like this. That as time goes on, every time you want to add new features, it seems to get harder and harder and harder because the existing code base kind of slows you down as you add more stuff. How many people have been on a software project that feels like that? Pretty much everybody. That's a big reaction. But it doesn't necessarily have to be that way. If you've got a good architecture and you pay attention to keeping it healthy and refactoring regularly and making sure that the software code base stays clean, you can get a different experience where not just is that slowdown attenuated, you can even reverse it and feel that I can build new features faster and faster because the software is already nicely componentized. So I just need to make a change here and a change there. It's easy to find where to make the changes, and I can accelerate because the software that's existing, the existing code base, is a platform that I can build up and go faster. How many people have had that experience on a software project? Less hands, but there's still quite a few of them. I ask this question every time I give this talk. I always get that same result. Lots of hands for the first, less, but still enough for the second. What we want is that second case, and that is why software architecture is important. Because yes, if I buy the product that's $100 cheaper and has low internal quality, I win at the moment. But what will happen is that the better internal quality software will be able to make new features more and more rapidly. And soon, the slower one can't keep up anymore. And we can probably think of cases, competitive cases, where we've seen this happen, where a product that's looked like it's dominating has ended up being eaten away over time. And that's particularly relevant now as we push more and more towards continuous delivery, continuous deployment, features updated over the internet all the time. That degree of being able to respond to change becomes important. And that's the economic reason why software architecture is important. Because if we don't keep good architecture, if we don't put that effort on internal quality, we are in the end deceiving our customers. In fact, stealing from our customers because we're slowing down their ability to compete. And that crossover line, where good design counts even in the short term, happens remarkably quickly. It happened when I talk to people about how long, it's weeks, not months. So that's the what and the why of architecture. I would like to talk about how, but I have 18 seconds left, so unfortunately that's going to be tricky. But fortunately, there's a whole track at this conference talking about the hows of software architecture, so I'm going to delegate all of that to them. And I hope you'll enjoy listening to them.